All right, now paper 3 is the last option or last paper. It's about the options. So if you scroll to the end of your formula packet, there is a top or section covered equations options. There are 4 options to choose from for paper 3. Now paper 3 is actually, you get the weekend usually to study for paper 3, and you only have to know this particular option really well. The paper is a little shorter than paper 2. It's similar in format of paper 2, where it's like fill in the answers. One thing I forgot to mention about paper 2 is when it gives you a box, you want to make sure that you put as much information as you can in this box as possible. They don't really generally mark you wrong for wrong answers. They're looking for right answers. So, for example, if the question wanted you to get 1.2%, and you somewhere in here have 1.2%, but you have all this random stuff in here, as long as you have that 1.2% in there and show a little bit of work on how you got that, voila, you got some points. You got the point. So when it says like 1 here, it's worth 1 point. They're good for one thing. That one thing being, hey, you get the answer. If it asks for 3 here, it's looking for 3 things. So make sure you kind of pay attention to the numbers next to the boxes. I forgot to mention that for the last video. Um, this is like how many points this is worth. So if it's worth 2 points, they're looking for 2 things. As long as you have those 2 things in this box, you'll get both those points. You, like I said, typically they don't mark off for wrong things. They're looking for right things because they have to grade so many of these that as long as you have it in there, like when it says 4 points, they're looking for 1 point for do you have the right equation? 2 point, do you have the right equation like substitution? 3 points, do you solve? Well, I guess I'd show my steps here, but like I can't remember how they scored this, but like 1 point could be for like the right equation, another point for being right algebra, another point for like the right answer, fourth point for being like the right um, variables or right units at the end. So like fill in as much stuff as you can in these boxes as possible to help you get a chance to bettering your score because you can't get it wrong. You can only get points right. It's kind of like fill in as much as you can, as much as you know in the box that's related to that topic. Um, so back to the topic on hand, paper 3, which is the options. The options are in the back here. There's 4 different to choose from. Option A, or option 1, is relativity. I would say avoid this option. It is very confusing. Um, we don't cover much of it in IB. We just don't have enough time to cover all 4 options, and this is the one that we just don't get to. The equations are tricky, the concepts are tricky. If I took the test myself, I think I would struggle. I would know some of these concepts, but there's just some that I would have to learn myself. So avoid this one. It's tough. But there's 3 that we cover in pretty good detail. The first one being option B, which is engineering, which is just applied mechanics, thermodynamics, fluids, and simple harmonic. You can call this simple harmonic motion. So it's basically just applying mechanics and circular motion and torque for the thermodynamics, fluids, and simple harmonic motion. The next option is C, is just applied optics, which is imaging. And the subtopics of that are just like focal points, ray diagrams, magnification, medical imaging, and fiber optics. Then there's astrophysics is option D. This one is about like brightness, luminosity, distances of stars is the one topic in there. Wien's law, luminosity again, Doppler effect, distances of stars, redshift, blue shift thing, and then cosmology, which is basically a density, Big Bang theory, dark matter, antimatter, things like that. HR diagrams, some general concepts. So we cover a good chunk of this, not all of it. We cover a good chunk of imaging, and not quite the medical stuff in detail, but we do go over in depth on engineering physics. So most students end up taking this section. You only have to answer one section. They're going to grade the first one you answer, so they go right in order. If you answer any questions on relativity, they're going to grade relativity. If you leave that blank, then they're going to go to engineering physics. If you answer any questions on that, they're going to grade that, and that's your score. If you leave that one blank and the first one blank, then they're going to grade this one. If you leave the first 3 blank, they're going to grade the last one. So that kind of helps you because all you have to do is study the last couple pages, last couple equations, ignoring this one, whatever option you pick. So you want to make sure you try to pick an option before you take the test, so you're confident in that particular option, and just study it. You got the whole weekend to study it. Know what these equations are for engineering physics. Know what these if you decide to do that one. Know what these equations are, what the topics are for imaging, etc. Also, some things that can help you is there's going to be 5 questions. No matter what you do, no matter what you choose, there's going to be 5 questions. Question 1 is going to be about chapter 1 in your book. And chapter 1, if you remember, is about measurement, uncertainty, error in your measurements, and experiments. So question 1 is going to ask you some sort of experiment. Here's an example. It's going to give you a graph or something, and it's going to say, this student did this experiment, they graphed some data, tell me as much as you can about this experiment. Find the y-intercept with significant figures. Find the slope, find the uncertainty. Find the slope, find the uncertainty. Solve for when the speed of sound is 0. So this experiment was about the speed of sound at different temperatures. Then another experiment. So it's all about just general concepts. Here's another example. Let's go down. I have 2 different versions here. Here's another experiment for another example paper. Did an experiment with this. So ask you questions, general questions about experiments. So we'll do some practice with that. They'll give you a graph or something. Reading graphs, looking at units, usually like analyzing y equals mx plus b, or curves and linear relationships, looking at relationships between data, uncertainties, things like that. That's what the first question is going to analyze for the paper, for everybody. So everybody answers that same question. Then you get to choose your topic. So it says section A. Answer all questions for section A. Write your answers in the box provided. Then when you go to section B, after section A, it'll be different options, engineering physics. You just have to pick one of those 4 options and answer the questions. So for example, engineering physics is going to ask you a question. So engineering physics is all chapter 10. Imaging is all chapter 11. Astrophysics is all chapter 12. So you can use those chapters as kind of like a reference and some notes to look through, as well as some as you're studying for that section. Like I said, you get the entire week to study for it. But anyway, so engineering physics is going to ask you 4 questions in that particular topic. The first question is going to be about circular motion, mechanics, and torque, about these equations basically. The next question is going to ask you about thermodynamics, basically a PV diagram, internal energy, work, efficiency, Carnot cycles, something along those lines. Third question is going to ask you something about fluids. Usually it's something with Bernoulli's principle, this equation right here, or something with this equation where it's like flow rate. Sometimes something about viscosity, but usually these are the main 2. Bernoulli's principle is a big one. Then they ask you something about supersonic motion. I'll give you an example of that. What they could ask you with supersonic motion. They could ask you a question. So here's a Bernoulli's. No, this is like a general concept about Bernoulli's principle, laminar flow, and the supersonic motion, about different graphs and how the waves are slowly dissipating energy and becoming less and less steep. That's usually something about damping and supersonic motion. So that's the engineering physics. So we covered all those in pretty good detail in IB here. Imaging, they're going to ask you a question about ray diagrams. The first one, they're going to ask you something about calculating magnification or focal points or angles using ray diagrams. They're going to ask you something about fiber optics. In these 3 topics, we go into pretty good detail in. But then the medical imaging question, they ask you something about X-rays and like how the imaging affects the human body, how can NMRs, things like that. If you're taking Chem IB, you probably recognize some of this, or Bio IB. They probably talk about a little bit scanning electron microscopes, things like that. We sometimes get enough time in class to cover those, but it really depends on the year and depends on how much you get through. I typically don't have enough time most years to cover this section, so it if you decide to do imaging, make sure that you